Hey everybody, we're live with another Snowflake live stream, this time covering all things new with AI Observability. And today I'm joined by the product manager for AI Observability, Anubhav Mishra. Anubhav Mishra came to us from AWS, where he worked a lot on the Guardrails product and has been with us for about a year now. So it's been really fun working with him and helping AI apps become more trustworthy in the Snowflake ecosystem. So welcome.
Hey everyone, I'm Anubhav, as Josh introduced, have been working on the AI observability pieces. Super excited to share what we have on AI observability and how it can help folks. Hi Josh, how are you doing today?
Yeah, doing good. Excited to see you.
Cool.
So maybe we can start off, and if you can frame for the audience just what is AI observability, why should they care, and like how should they think about it?
So AI observability broadly can be categorized under three different areas or three different sections, and it helps in essentially analyzing and monitoring your GenAI applications throughout your application development lifecycle. So think of when you're starting to build your application, you want to do some ad hoc testing, you want to test using like one or two single utterances, but you really want to know what's happening within the application. That's where tracing comes into play. And tracing is one of the critical components of AI observability, where you can see like what are the sequence of steps that the application took. What in the case of AI agents, what are the different LLM planning steps that an LLM ended up taking? What are the different tool calls that have happened? What were the different arguments that went into the tool? Because these are like really important for debugging. The second aspect of it after tracing is evaluations. This is the place where you would want to systematically evaluate your generative AI apps. Now, an application requires, prior to deploying your application in production, you will want to evaluate and come up with a more quantifiable measure of how your application is going to perform in production. And the third piece, of course, is monitoring. Once you deploy your app in production, you do want to monitor on an ongoing basis. How is your app performing? What does it look like? What are the kind of user query coming in? What's the data drift looking like there? And how do you continuously optimize your application? So all of this end-to-end encompasses the AI observability umbrella, and each of these stages are equally important.
Yeah, that makes sense. And just to like really make it concrete, can you share what kinds of apps customers have been using it for? As this like external facing apps? Is this chatbots? Is this like internal support apps? Provide some flavor.
Right. So when we started off, I think when the whole LLM picked off with like production ready performance, we saw a lot of these RAG applications initially take off, because there are a lot of these enterprises, and by RAG I mean retrieval augmented generation, where you can ingest your own internal enterprise knowledge base or data and can create a chatbot or a support agent to essentially answer any queries. Now, of late, where it's getting transitioned into is this whole paradigm of AI agents, where as the models are improving over time, they're also able to better reason, handle complex tasks, and execute tools on your behalf to actually accomplish an action. Now, each of these apps require varying degrees of observability and monitoring, given that the number of failure modes or the failure touch points increases with the amount of things that the LLMs are handling. And the nature of the apps, or the kind of apps, or any sort of GenAI app that you would look at, would require like evaluations and monitoring based on the degree of difficulty or the kind of use cases the apps are essentially trying to handle in this case.
Yeah, that makes sense. And what kind of failure modes are people like able to detect using AI observability?
Yeah, let me quickly share my slide. It will really be helpful to go through like a diagram here. Is my slide clearly visible, Josh?
I think, can you advance once?
Yeah.
Maybe if you, I don't know how many transitions are on the slide.
1 second. Is this visible right now? I'm just trying to.
I see the header on the slide.
Okay, cool. Do you see the query now?
Yep.
Okay, cool. Yeah, so as we evaluate AI agents, I think the number of failure points or failure modes happens at every stage of the agentic transition. So in the first step, where we look at when a user query typically comes into an agentic paradigm, what we look at is the quality of the prompt or the user input can dictate how the agent is performing. Did the agent actually understand the user query becomes one second dimension to it. Next step of it is, depending on the user query, the agent goes about planning, and what it does, here is that the query essentially gets broken down into a set of steps or a set of plans. And did the agent actually come up with a coherent set of plans based on the tools available in its disposal? That's another aspect of the evaluation that you need to do. The third aspect of it is tool selection. Now, each step in the plan ideally needs to get mapped to the right tool so that an appropriate tool is executed to get the required results. Now, was the tool selection or tool mapping conducted correctly? That is where you would look at another dimension of evaluation. If this is not evaluated correctly, the tool mapping can be incorrect and your agent may not be performing optimally. Within the tool, there are a variety of tools that an agent would have access to. You typically go about looking at web search, knowledge-based search, which is where you can actually refer to your internal document or repository, structured data retrieval. In Snowflake, we have Cortex Analyst, which does structured data retrieval from your Snowflake tables, and eventually custom tools. Now, within each of these tools, again, you have a bunch of these failure modes where, let's say if you're creating your own internal knowledge bases, there are parameters that you can tweak and change to improve the retrieval quality or search quality, like chunking effectiveness, nature of the data ingested. Similarly, for Cortex Analyst, for retrieving structured data, you can actually modify the semantic model or the semantic view quality and iterate on it to improve the text to SQL evaluation. And all of these iterations require consistent and thorough evaluation at each step. And similarly for custom tools, was the right tool selected? Was the right arguments for the tool being captured or not? And finally, as the right tool is being selected and you execute on these tools, you look at the final response. And the most important thing here is to prevent hallucinations, where is the response grounded in the retrieved data or the tool results or not? And these are like the various failure modes we would look at in general in terms of as we are thinking through like an AI agent in development.
Yeah, this seems like a really useful framework and good way to think about it. I think there's no live stream without hopping into the demo. So do you want to show us in action?
Yeah, I think for the demo, let's just pick up a very simple RAG use case, retrieval augmented generation use case. Quickly to touch on the failure modes that we would look at, as we discussed earlier, knowledge-based search would have has failure modes around like how is the retrieval quality in, and finally the generation step has failure modes around did the response actually hallucinate, was the response grounded in the retrieved result or not. So in order to evaluate a RAG application, we have come up with this whole metric of RAG triad, where it basically monitors, looks into the query context and the final response. Now, depending on the query and the context, we measure the effectiveness of the retrieval quality, and we use a matrix called context relevance, which is where how relevant is the retrieved context based on the query being asked. The second aspect of it is as you pass on the context to an LLM to generate the final response, is the response completely grounded in the retrieved context? Did it add any new information or did it contradict any information? These are the things that can be measured using a groundedness metric. And towards the end, we have answer relevance. As the final response is generated, is it relevant to the query being asked or not? So this encapsulates the whole set of triad metrics that we look at from a RAG application perspective. And now let's quickly jump to the demo here. So what I've done here in a demo is I've created a Snowflake notebook, which has a RAG application built in. And as part of the retriever, we are using Cortex Search in this case. So we are getting the context of the session. We're setting up the context search retriever. There is a quick start on how to set up Cortex Search retriever here. So we have set up the Cortex Search retriever here and created a retrieve function that can take in a query and generate the results. Next step, we are setting up our environment variables to enable tracing. We are using a framework called TrueLens, which is also available as an open source offering that you can use. Next up, we're using creating a RAG application. And as you can see here, it takes in the retrieve context function that we just defined as part of the Cortex search. And then it uses a generate completion function here that we are using, which is used to basically call the LLM to finally generate the final completion. And we have a query, which basically encapsulates first the retrieval, querying the Cortex search, and secondly, the generation, which takes in the result from Cortex search and then generates the final response. As you can see here, we are adding this at instrument tag to each of these functions. What this at instrument tag does, or the decorator does here, is basically it monitors that specific function call so that every input and output that's entering into that function can get recorded and registered within your Snowflake environment as part of the AI observability offering so that you can granularly debug what has gone inside each function call. And we'll see how that looks like in the UX shortly. Next step, what we do is the goal of this RAG application is we're trying to experiment using a Llama 3 and a Mistral Large 2. And we'll try to see which one of these model actually performs better in this context. So we are creating two different versions of the application, one using Llama and the other using Mistral. We are defining an evaluation dataset. These are the inputs that will be tested for, and we can compare how each of the two different models performed against each of these inputs here. And at this step, we are defining what those evaluation configuration are. We are giving it a run name. So that an evaluation run essentially has a name. We can give it a description. And then we are mapping a data set. So this data set goes back to what we have defined here. We are mapping what the inputs to the data set are going to be. And for both of Llama and Mistral, we will then basically trigger. So the run.start essentially triggers this application. And as part of this, what happens here is it takes every input in the dataset and loops through the application, generates the traces, and transfers the traces into your Snowflake secure account perimeter there. And once all of those traces, inputs, and outputs are generated, finally we compute the three metrics that we just created again. So I think one interesting thing to note here is that none of these three metrics actually rely on ground truth. So as you can see, our dataset only contains the input. So we are using LLM as a judge to essentially evaluate how good the responses are in comparison to based on the question being asked. And finally, we can see the results here in Snowsight. So all we do is we go to the AIML tab, click on evaluations, and we had registered our application here. So I'll see a list of all of my applications in this case. And so this FOMC RAG chatbot is the one that I had registered for that. As you can see, there are a bunch of evaluations that are being done in this case. And we have run a few experiments. I think this one was on Mistral Large 2. This is on Llama 3.1b. As I click on one of the experimental run that we had, these are the inputs that we ran our evaluation dataset against. These are the outputs that the application generated. This shows the duration or the latency each query took, and these shows the metric results for each of them. So these are, and you can see the aggregated metric as well at the top of the run. And now for debugging into each individual record, let's say we go into this as to what happened with the 0.25 score, right? You can actually go in and you can see the detailed trace of what has happened at each step. So the query was the parent function that we had instrumented. This represents the Cortex search call. And then finally generate represents the completion. And as you can see, there are three different metrics we have generated here. And if we look into context relevance, we can see like what the query was, what was the retrieved context from the search service in this case. And then a score of 0 essentially tells, and then there is an explanation associated with it. So this could basically mean that you have either not ingested your data into the search service in this case, and that's why the relevant results weren't being fetched. Or the other aspect could be you'd want to fine tune your data for more relevant results. So each of these metrics that we're looking at comes with a set of output and a natural language explanation of why it thinks the relevant score is justified. So this is the piece how you can actually debug each and every aspect and actually see the evaluation results. One other last interesting piece of this demo here is that you can also compare two different runs, in this case, in a side-by-side scenario, to actually see for the same input, what were the different outputs generated, how did the models perform, and which configuration to go up with. And you can see these on a side-by-side basis. In this case, it looks like both Llama as well as Mistral actually did the same. So there seems to be a definite problem with the retrieval setup in this case. So yeah, I think that's the way we would go about analyzing all of these configurations. And if you look at the aggregated metric, as you can see in this scenario, the groundedness, Mistral has done a better job at groundedness comparison to Llama 3.1 for this specific test set. The rest of the metrics remain more or less the same. Answer relevance again, Llama is a little higher. And you'd want to index on one specific metric based on your use case. If you're indexing on accuracy, groundedness becomes the key metric. Over to you, Josh.
Yeah, can you explain one more time about like how the LM judge is able to like generate both the score and then the explanation?
Yeah, so if we look at one of these records going back, right? what the LLM judges are essentially custom prompts that we are managing on the Snowflake side to ensure that you get consistency in this evaluation scores. And the way it works is it essentially takes in the final output as part of the prompt. It takes in the input as part of the prompt. And then we have developed a set of customized prompts which asks an LLM judge that given this output and given the input, do you think the response is actually grounded on the output? And then there are quality criteria assigned to the LLM judge that if all the content is grounded, mark it as a score of 3. If partially a certain amount of content is grounded, then it gets a lesser score. So there is a very customized prompt that we have used, and we have also done a bunch of prompt optimization to ensure that the deterministic aspect of how these scores are generated are pretty much consistent. And there is a blog that can be shared as well, where Snowflake has published a blog where we show how these performance on optimized prompt for relevant judges look like.
Awesome. Yeah, super important to be able to like trust the evaluator here.
Right.
I really love this workflow you showed where you're able to compare the performance of different LLMs in like the whole like system RAG setup with like new models being released all the time with the pace of AI these days. It's like a super important workflow, especially if you want to add new LLMs into production. I could see you doing this both as a gate step before you do that. Are there like any other common types of experiments people are using other than comparing LLMs?
Yeah, I think there are a bunch of these configurations that needs to be tested, right? And as we discussed about the agentic scenarios earlier, you would want to configure, as you're building your GenAI app, you are experimenting with a bunch of different prompts. So you'd actually want to do a comparison based on how does one specific prompt work for a certain model in comparison to the other one. As you're building your RAG application, one key aspect of it is the retriever that you set up. So you might be using your own vector stores. So how well the retriever setup is, how is the retriever performing, is it actually retrieving the right set of result, the context relevance metric actually helps in that. And as you're looking at more advanced agentic scenarios, evaluating tool selections is important. Evaluating is the right arguments sent to the tool, that's really important. Evaluating if your output is grounded in tabular, let's say if you're fetching tabular data or structured data from Cortex Analyst, is the final response grounded in your structured data? That's important. So there are like all of the failure modes that we have discussed earlier requires its own set of independent evaluations, and that is something we're trying to simplify going forward as well.
Awesome. Yeah, it makes sense. And I think you mentioned before this is like primarily used in a development setting. Once somebody deploys an application to production, do you recommend any regular retesting of the app?
Yeah, absolutely. I think one of the key aspects and key dimensions to ensure that your application continues to perform the way it's expected to is to do continuous testing on real production data. And that's where these metrics that does not really require a ground truth also helps in simplifying that workflow. So ideally, the recommendation here would be to sample a set of production inputs and the relevant outputs that were generated and iteratively run evaluations across those sample set to just see if the final set of metrics that you generate based on those evaluations are in line with your existing evaluations or not. Because more often than not, what happens is there might be scenarios where your business use case might have changed a bit, or the kind of users you're targeting may have changed, and the kind of data that your application is handling may have drifted. And in that case, your application may not be performing as you had originally intended to and would require further iteration. So continuous evaluation helps you in surfacing those kind of data drifts that may have happened. In addition to that, as you are adding new use cases on your existing applications or agents, you should continuously evaluate and iterate on it going forward so that all of those existing use cases work as expected without negatively impacting on any of the existing ones.
Got it. That makes sense. So I think one of the reasons we wanted to meet up and do a live stream today is because AI Observability has a milestone coming up. Can you share a little bit more about what milestone is going to reach?
Yeah, so this offering that you saw here has been available in public preview since April. Next week, we are launching AI Observability in general availability, and it should be available to all the customers out there in all commercial regions going forward. And we are super excited about it because it truly unlocks the capability for any and every customer out there to test their GenAI applications going forward. And the key things as part of GA are like improved stability, improved failure-based retries that we are introducing. We have figured out certain, so based on customer feedback, we also smoothen out some of the rough edges and rough surface area, improve the stability of these scores going forward as well. So I do look forward to how customers are using it and getting more feedback and adding more and more capabilities on top of it to simplify these GenAI development lifecycle.
That's exciting. Yeah, I think it's going to be awesome to see how many customers can help add trust to the RAGs and agents they're building with this new offering in GA. So of course the work is never done, right? So what's next? What are you working on to even improve AI observability?
Yeah, I think like when we think of AI observability, we think of the core inference API. We think of the Gen AI apps, right? And they can be broken down into two different components based on how our customers use it. So there are a set of customers that are using our core inference API, which is the complete function, and are creating their own generative AI apps. There are customers who are using other cloud vendors as well, along with other service providers from Amazon, Google, Azure, creating their own generative AI apps as well. So the offering that you see today or that we are already launching is meant for observing, evaluating, and monitoring generative AI apps that you have created yourself. So that's like one dimension of self-created custom apps where you can actually monitor and observe. We are also launching or enabling native observability on Cortex first-party apps that we have, or Cortex native services. So we have Cortex agents, we have Cortex search, and we have Cortex analyst. So next up, we are looking at enabling and embedding observability, evaluations, tracing, and monitoring natively as part of these applications as well. And finally, we are looking into right now, as you see, like there are a set of out-of-the-box metric that we support for certain targeted use case. We will also be enabling custom metric going forward so that any custom use case that you might have, you can write your own LLM as a judge prompt and basically go about evaluating and storing those in the infrastructure. So that's like where it would basically boil down to. And the way it works right now, and I'll just quickly share this final slide in terms of how the underlying infrastructure looks like and what benefits it does bring about. So just is my slide visible right now? Let's check.
Yep.
Cool. So the way it works right now is behind the scenes, what happens is irrespective of where your application is running, you can instrument your app using the decorators that we shared earlier. And the data can then transfer the traces that we see transfers into the Snowflake secure perimeter boundary, which is where you conduct your evaluations, storage, and the native visualization on Snowflake for. So in a way, you can think of it as once your application is executed and once you have emitted all your traces to Snowflake, everything is in a secured boundary within the Snowflake environment, and you can use your Snowflake account to host this data. And we'll be adding more custom metric and native visualizations for one piece of this going forward, as I was calling.
Awesome. So can you explain a bit more? You can leave this slide up for a second.
Mm-hmm.
If I'm building my application on-prem or like in some other cloud, how do I actually connect it back to Snowflake so I can send the logs and run the evals in Snowflake?
Right. So we use a SDK called a TrueLens SDK, which is available both as an open source as well as a native product capability within Snowflake. So if you're building your GenAI application in any other environment outside of Snowflake, it could be on-prem, could be your own local environment. All you need to do is import the TrueLens SDK into your application framework. Use the @instrument decorator that I was talking about earlier to actually decorate the functions that you want to monitor. And as you instantiate the TrueLens SDK, it takes a Snowflake connector, which is where you provide your Snowflake credentials. Once this is done, everything is taken care in the backend within the SDK code itself. So as you run through your triggering an evaluation run and then computing the metric, the TrueLens SDK behind the scenes generates the traces in OpenTelemetry compatible format, transmits the traces to the Snowflake event table. It's a managed event table in your environment. Transmits the traces to the event table using the Snowflake credentials that you would have provided. And once it reaches the event table, the computation is all done server side within the Snowflake environment by using your own warehouses. And the visualization is available on the Snowflake dashboard. So in a way, you can think of it as the application can run in any environment. As long as you're using the TrueLens SDK to instrument and monitor, the traces will be transmitted to Snowflake using a secure connection and then continues to stay within the Snowflake environment.
Awesome. So the key thing people need to do is just like set that Snowflake connector in the TrueLens SDK.
That's right. That's absolutely right.
Cool. I think like one other concept I wanted to make sure like we got to explain the difference was between this evaluation workflow people use today and that we've just talked about, and then what's coming with observability for like Cortex native products. I think like even in the example you showed, we had like a RAG, but we were still using Cortex Search and Cortex Complete.
Mhm.
Like what additional visibility will people get into some of these like Cortex native offerings?
Right. So as we are thinking about Cortex agents, right, I think agentic workflows are going to be more popular, and Cortex agent is the native offering that we will be providing with tools such as Cortex Analyst and Search. Right now, with a custom application that you create, you still have to use the TrueLens SDK at instrument decorators. What we are looking at is we're trying to simplify that process even more for the first party Snowflake products and Cortex agents that we are launching. So as you build out your Cortex agent, what you get out of the box is you will be having a breakdown of what are the different steps that the agent took, which tool, which search service, or which analyst did it end up triggering, what were the LLM planning steps. And none of this requires any code or any custom instrumentation, as was the case with creating or observing your own apps. This all comes out of the box, directly available to you within the agent admin developer console or developer experience itself. So as you are testing your application, writing a question in a chat interface, you will start seeing the live traces simultaneously popping up so that you can immediately debug what's going on, what's happening. And as we go forward, we will be enabling evaluations on more evaluations from an end-to-end perspective. Or did the agent take the right trajectory? Was it the most optimal? Did the agent falter at any step? Those are the kind of evaluations and root cause analysis that we'll be providing more natively as part of Cortex agent. So if I have to summarize two things, first of all, the nature of the metrics will be more informative, given that we have visibility into how the planning and what are the steps that the agent takes going forward. And the second aspect of it is the dev experience is going to be extremely simple, where you do not have to do anything. It's just available out of the box to you in a no-code environment using a UX.
Awesome. Yeah, I think that's like a really huge unlock for people building with Cortex agents already, is that they'll be able to actually really understand what's going under the hood. That like both helps with debugging and just like better understanding the agents you're building.
Absolutely. Yeah.
Awesome. Well, this has been really fun. I really enjoyed getting into the details. Is there anything last you want to share with the audience before we wrap up?
No, I think we're looking forward to how customers and users are going to use AI observability once we make it available in GA. And it's going out GA next week. We do want folks to try it out and provide us feedback. So definitely looking forward to more usage and feedback there and how we can improve the product.
Awesome. Sounds good. Well, thanks so much, Sean and Bob. See you later.
Yep. Have a
Thanks
good
for
one.
tuning
Bye.
in. Bye.